This video will handle with the auto orchestration of Sonus SBC SWE by the HPE NFV director. The initial environment consists of an OpenStack infrastructure, HPE Lion or Wind River, also referred as a VNFI, of the manual layer represented here by the HPE NFV director, and of our cloud EMS on which the Sonus SLS is onboarded. We will also make usage of a code generator, CP, for code traffic generation, and of Cielometer, the analytics part of OpenStack that will provide us metrics or KPI relative to the onboarded elements. The first step of this testing scenario starts by a manual provisioning of Sonus SBC clusters, the configurator cluster and the traffic handling SBC SWE cluster at the EMS level. The second phase of this demo consists of creating a configurator SBC through the HPE NFV director. This instantiation is manually triggered at the NFV director level. Once the configurator node created, it is possible to provision an SBC configuration and to save it locally on the EMS. Here is a recording of those previously described phases. Of course, we have hidden the preparation and configuration that has been realized in the HPE NFV director. We start by deploying the configurator node. This is a one-click action on the HPE NFV director. We check the deployment state. Each of the OpenStack deployment steps is being displayed graphically. At the bottom right of the screen, we can observe the OpenStack dashboard in which a new instance appears. This is our newly created configurator. Once the VM is up and running, its status becomes OK in the director GUI. Finally, we check the SBC application is running and started via the console screen, and that the configurator registers on the EMS. The number of online nodes turns from 0 to 1. The third step of this video is to create the first node of our traffic handling SBC cluster. This is done via a manual operation on the HPE NFV director. Once created, the SBC SWE registers on the EMS and retrieves the configuration linked to its cluster. Now we can start running some voice traffic and check the CPU level of our node at Cielometer level. HPE NFV director has the capability to poll Cielometer in order to display graphically the CPU level of our node in real time. We increase the traffic load a little bit and check that the CPU is increasing as well. Here, we increase again the load of traffic in order to reach the threshold that we predefined in the HPE NFV director. This triggers an action that leads to an automatic deployment of a new node in order to scale out the SBC cluster. Thanks to all the automatic procedures in place, the new SBC SWE retrieves its configuration, gets up and running, and the traffic is shared between the nodes without any human action. This results in a global lowering of the CPU of each SBC instances. This recording shows this phase of autoscaling. We start by generating some voice traffic and check the CPU level. We configured the threshold to 15%. When this limit is reached, a new instance is being automatically spun up by the HPE NFV director, following the exact same procedure as previously when we launched it manually. Here, you can observe that the instantiation is successful on the HPE NFV director as well as on the OpenStack. While the Sonus SBC application of this new VM is not started, we can observe that all the traffic is being handled by a single SBC, the first one we created. But once the application is up and running on the newly created SBC, we can observe that the traffic is being load shared between the two entities of this cluster. This is what you see on the line 302. If we increase again the load of the traffic and reach the threshold limits, a new instance is being launched by the HPE NFV director, following the same steps as previously described. Once this new node is attached to the Sonus SBC cluster, the call traffic is being load shared between the three elements. This can be reproduced a certain amount of times. Thanks to a lowest threshold, the same behavior can be observed for scaling in the number of VM within a cluster. Thank you for your attention.